Welcome to the ProvelCAD tutorial on transfemoral by measurement socket design. I've recorded some measurements for Mr. John Deere. In his case, I've taken length and circumference measurements in millimeters over a locking liner. So let's start here, AK by measurements. And we'll key in the pertinent information. You have right or left. In this case, we'll go with right. You select a brim. I like this one. I'll show you a comparison a little later. And we'll key in a length measurement. This optional one I don't tend to use too much. I have an AP. If you do use them, I would just choose the one that is most important for the patient. My tools measure AP more effectively, so that's the one I'm going to key in. And some circumference measurements. I'll just go ahead and key those in. And apply. The last box is optional. Look it over. Here's where you might want to compare different brim styles. For instance, we'll double click there and pick another style. How about this one? And then go back. If after your measurements are entered and it doesn't look right, changing one or two of them typically fixes it depending on the selected model. The first two entries to look at are the length where it indicates the last box is optional, or the zero level where the trim lines are involved. Changing those will often take care of it. So from here, let's explore a couple of the functions mentioned in the transtibial tutorial that may also be applied here. We can modify the distal end to incorporate a shuttle lock and define the merge taper. So let's do that. Okay, this basket merger, that would be used if you want to design a hybrid socketless system. Let's just go with normal, and a normal 63 millimeter lock. Let's see what that looks like. Translation can be used here as well as on the transtibial models, but I usually rely more on alignable components with transfemoral. And you can define here a merge. That's this line. So if you bring it way up there, it just transitions different. But you'll see what we're talking about. Let's see what that looks like. Okay. Let's also create a custom trim line, and then from there I can show you how to turn it into a template to reproduce on future sockets, and also that minimizes potential fabrication errors. So this one, we're starting it from scratch instead of applying. So we'll go over here to trim line. I kind of like this at 5. The height and the offset, just from how it gets to the, from the handle to the apex. And here's where we just pick our points. Okay, look this over, add it accordingly. That just gave us our defined our point. And you get the idea. You get something that you're happy with there. Just apply it, and you have a trim line. Now, if you want to use that, you get it just what you want, and you want to use it on future models, all you need to do is create a template, and then you name the template. So let's do AK by measurements, trim line, and we'll put it in templates. Makes sense. I already have one, but I'll replace it. Okay, now we just save it as a socket. And all that's left is to export for fabrication in AOP format, just like before. AOP, save it. And remember to let your central fab facilities know what you want them to create. Thanks again for taking the time to watch.